right, so let's do another one. Okay, again, I hope I'm not going too fast for anyone. I do want to finish the chapter, but I don't want to go too fast that nobody understands this. So I want to make sure everyone learns this. So we're going to find the perimeter of this shape. Reminds me of the track that they have on campus, I guess, almost. Okay. All right, so we want to get the perimeter. So how would we do that? Well, we would have to get, the distance around the outside of the object. In other words, if you imagine like this was the track, let's say, and you imagine walking along from some point in one direction, right? We want to know how far would you walk? I mean, really, you can probably tell the only hard part is figuring out what the length of this is, the semicircle. And same thing on the other side. Okay, but hopefully I put this here, hopefully you notice that the two semicircles here, they each come from a circle with diameter 14 centimeters. If you go back to the previous slide, and when we looked at circles and semicircles, right? The edge here was the diameter of the original circle. And so half of this is the radius. And that's good, right? Because once you know the diameter, you can get the corresponding circumference for the original circle. So this came, let's say, so this semicircle came from a circle whose diameter is 14 centimeters, right? Now, how would you get this distance? Well, the circumference of the original circle would have to be pi times 14 centimeters. That's for the original semicircle. Oh, we're doing area for? Oh, I thought I was doing perimeter. I'm sorry. Yeah, we'll go back to area. So sorry if it's a little out of order. So the original circle was 14 centimeters. Okay? The diameter, that is. Well, then the original circle had a circumference of pi times that. But this is a semicircle. So we do pi times 14 centimeters over 2. Now that's for each semicircle. So again, this is for perimeter. So we have 14 pi over 2. That's this length. And we're rounding that to decimal places. Okay. I'm using 3 here because we want to round to 2 only at the very end. So each semicircle here is giving us this many centimeters. We have this is 32 centimeters. This is 32 centimeters, right? So all together, the perimeter of this thing, you add them up, and then we round. I really hope that made sense. Okay. That's for perimeter. Again, you just basically have to figure out what the length of this part is. Again, just think about the original circle and whatever you get, divide by 2. That's what I did. Okay. Yeah?
Would you have to show how to put that in the calculator? Because I'm not getting the right answer.
You do 14 and then times it by pi, and then you would divide that by 2.
I keep doing that, but I don't know why I'm not getting.
Did you do 14 times
I
pi?
keep getting
and then
20. I'm sorry.
What, say that again?
I keep putting 14 pi divided by 2, and then I get 21.991.
Maybe let me see if my answer's right.
Oh.
Should be times pi divided by 2. Yeah, you're right. Your answer's right. My mistake. That should be 21. Let me fix that quickly.
Oh, okay. Thank you.
You're welcome. Sorry about that. Fix that quickly. 107. My mistake. I missed that when I went over this, when I went over the lecture notes. All right. So that's for, so thank you for catching that. Appreciate it. So that's for perimeter. Okay. So even though I had a mistake here, yeah, this should not be in 49. This should have been half of that. So actually, let me fix that. There we go. Okay, so that's for perimeter now. So now let's go for area, okay? So area, the idea is really just like the previous example, okay? Remember, think about the original circle, right? I mean, you generally want to break up the region into regions where you can easily find the area, right? I mean, you can hopefully see from here that we have a rectangle, right? A rectangle whose base length is 32 centimeters and whose width, or I guess you could think of it as height, the height of the rectangle in the plane is 14 centimeters. So this rectangle, it's easy to get the area of. Okay. But what about the semicircles? Well, again, think about the original circle. If the diameter is this came from a circle whose diameter was 14 centimeters. So the radius of the original circle was, wait, you know what, maybe this will help. For the original circle, bear with me, the radius would be 7 centimeters. Oh boy, that's awful. Okay, that I know it looked kind of awful, but hopefully you get the idea. The original circle had radius 7. Well, how do you, 7 centimeters? How would you get the area of that? You would do pi times 7 squared. Right? Oh, but it's a semicircle, so you divide that by 2. Okay? And that's what we get here. Hold on, wait. Is that a question? Yeah?
Why is it 2 squared?
I can't hear you.
Why is it 2 squared and, I mean 7 squared and not 14?
Louder, I can't hear you.
She said, why is it 7 squared instead of, I didn't catch the last part.
14.
Because
14.
you want to use the radius, that's why. And the 14 is the diameter. Because remember, for the area for a circle, it's pi times the radius squared. And here, this came from a circle. It's a semicircle, and it came from a circle whose diameter is 14. So the original circle's radius would be 7. Does that help, or?
It doesn't, I guess, I don't know.
All right, I mean,
Sort of, I guess.
I mean, if you go back to the, what do you call it, the slide we did, I think it was last class when we looked at semicircles. To get the area of a semicircle, you take the radius of it and square it. You multiply that by pi, but you have to divide by 2. It's a semicircle.
Oh, okay. Thank you.
Okay. I mean, I hope I answered. Hope I was able to help. So,
She said thank you.
any other questions? Okay. Thank you. Any other questions? Okay. Good. Okay. Okay, so, but that's basically what we're doing here. You get the area of each semicircle, and you add on the area of the rectangle. And that's what we get. Okay, so, all right. Okay, so with that said, the perimeter already, let's now move on to this. So I'm not going to do too many word problems. I'm not going to get too crazy with them. They do a few in the book, and I just thought it'd be good to like maybe do 1 or 2. And basically with word problems, I have some kind of strategy. I have a strategy here. I mean, you don't have to memorize this. Well, you don't, I mean, definitely because the exams are take home. But I mean, this is what the strategy is. You basically, of course, have to read the problem. I know that's kind of obvious. It's good to draw a picture if you can, because that really can help you understand what's going on. Even when when I do word problems, when I taught calculus, I tell the students, draw a picture, because it's easy to see then it makes it easier, I should say, to see what the situation is and what you have to do to solve the problem. You may have to choose some variables like r for radius, x, or whatever. And generally, using the picture especially, you might need to come up with some kind of equation that you have to solve. And with the pictures, you'll see in the examples, we'll do today. From the picture, you can easily get that equation that you have to solve. So after reading it, the problem, you draw a picture, choose your variables, use what's given to you. Use your picture also to come up with some kind of equation so that you're writing out mathematically what you have to do. Then, of course, you solve, and it's good to check your results. Okay. All right, so I mean, that is the strat. They have this strategy for word problems. I think it's also in the book, actually. Let me just pause the recording.